All right, guys, here we go. Last video of chapter 2. We're going to look at one-to-one functions, the last thing on functions, and their inverses. Let's get this going. All right, one-to-one means not only, this is like a quote for me, not only does every x have one y for it to be a function, but every y corresponds to one x. You can see the picture here. This is one-to-one. Look at all the x's going to one y, a going to b. But if you look backwards, all the b's are also going to one. So that's one-to-one. This one is not. This is a function, by the way, because every x, if you look at everything in here, it's going to one place over here. But if you start to go the other way, 4 would be going to 2 different places. So if it's one-to-one, every x has one y, and every y corresponds to one x. The horizontal line test is a graphing test you could do to see if it is one-to-one. If you draw a horizontal line and it intersects the graph more than once, it is not one-to-one. So this first one right here, that is one-to-one because you can see all the horizontal lines going through the blue graph only intersects at one time. That is one-to-one. This one is not. Those red horizontals are intersecting the blue more than once or twice. And this third one down here, that is also one-to-one because all the red horizontal lines intersecting the blue graph only once. So that is one-to-one. That's the easiest way to tell if something's one-to-one. The tougher way to tell is like just trying numbers. Like this is f of x equals x cubed. If you plug in 1 in for x, you get 1 for y. If you plug 2 in, you get a for y. If you plug -1 in, you get -1 for y. So what's happening is every x has exactly one y, which is good. But also if you go the other way, all the y's are just having one x. So look at this one. This one, if I plug in 1, I get 1. If I plug in 2, you get 2. If you plug in 3, you get 9. If I plug in -1, I get 1 again. So that's a function because every time I plug something in, I'm getting one answer. But that 1 right there, the y, corresponds to -1 and +1. So that's not one-to-one. And the last one right here, I would do the same thing. If you plug in 0, you get 4. If you plug in 1, you get 7. 2, you get 10. So what's happening is every x is corresponding to one y, which means it's a function. And also this time, every y is going to just one x, so that it is one-to-one. So it's a little bit easier just to graph it and see if it passes the horizontal line test, but you can also do it algebraically. Definition of inverse is basically your x's and y's interchange, your domain becomes your range. It says let f be one-to-one function with domain A and range B, then its inverse function is domain B and range A. Basically your x and y's interchange or switch. The domain of the inverse is the same as the range of the function. The range of the inverse is the same as the domain of the function. They just switch. Remember, domain are x's, range is your y's. They just interchange or switch if they're inverses. Inverse property, this is an important one. To test to see if two functions are inverse of each other, you do a composition like we did the other day. You would do like the inverse of f of x, and it will equal x if they're inverses. And if you do f of the inverse of f of x, wow, you also get x. You get x every time, both ways, if they're inverses. And that's the test. That is the test to see if they're inverses or not. Let me show you an example. Okay, this one says show that they're inverses. So to show, you have to do f of g, and you got to do g of f. You got to go both. If I do f of g, I'm going to plug g into f right there. So it's going to look like this, x to the 1/3 cubed. And if you were to not remember with a power to a power, you multiply your exponents, so you just get x, g of f. Now you're going to plug f into g, so you're going to get x cubed to the 1/3. And again, you're multiplying exponents, you get x. And because you get x both times, they are inverses. They are inverses because they both equal x. And that's the key. They both have to equal x to be considered inverses. Okay. Another thing we're going to do with inverse is actually find the inverse of a function. So it's really just 2 or 3 steps. The first thing to do is you plug in the y where the f of x was, because it's, f of x is just function notation for y. Then the weirdest step is we're going to just interchange the x and the y. We're just going to switch them around. Then we're going to solve it for y, and the resulting equation is your inverse for y. Remember this notation right there, I should have said this earlier, the little f -1. That means the inverse of f of x. When you see the -1, the inverse of f of x. I should have said that way earlier. Sorry about that. Okay, find the inverse here. If it says find the inverse, here's the steps again. You switch your x and your y. You interchange them. So I'm going to put the y where the x was, the x where the y was. Then you're going to solve for y. So I'm going to move the 2 over and then divide by 3. And that represents the inverse. Now, I want you to write it like this. I want you to put the little inverse notation. But that is the inverse. That's all you do. So again, put the y where the f of x was, interchange your x and your y's, and get the y by itself, and that's it. Okay, let's do one more of those. Find the inverse of this one. So just a quick review. Put the y in for the x. Well, I'm going to go ahead and switch the x and y just to make it a little quicker. So I'm going to put the y over here, the x where the y was. And then now my job now is I have to solve for y. So I'm going to multiply both sides by 2. Move the 3. And then to take the 5th root. That's the way you get rid of the 5th power, is you take the 5th root of both sides. And I'm going to go ahead and change this to inverse notation. And there it is. So one more time. Steps. Put y in first of all. Switch, interchange your x and y. Solve for y. Plug back in your right notation. And you're good. So one more slide. Last one. Graphing the inverse of a function. This is awesome. This is interesting. And we're gonna learn this right here. They reflect across the line of y equals x. Okay, I'm going to graph this first. This is one we've done before. It's a square root graph. It crosses the, it's been shifted 2 to the right. So I'm going to start there. I'm going to go 2 to the right. There's nothing in the front, so I'm going to go up 1 over 1. The graph would look like this, kind of like that. All right, now, the inverse, let's just find the inverse. I want to show you something here. If we find the inverse of this thing, I'm going to go x over here, y over here. I'm going to square both sides. Move it up, move that 2 over, so I get this, x squared plus 2. Now think about it, and that's really this notation also. X squared plus 2 is a parabola. It starts up 2, so it starts here. It goes up 1 over 1. Whoa. And because inverses, they must be 1 to 1 to have an inverse, I'm only going to graph half the parabola. Because if I graph the whole parabola, it would fail the horizontal line test. That's called restricting your domain. If I graph the whole parabola, it would fail the horizontal line test. It will not be 1 to 1, which means it would have no inverse. 1 to 1 functions pretty much all have inverses. So watch this. I'm going to graph that line y equals x. Think about this. Y equals x. The points it would work in it would be like 0 equals 0, 1 equals 1, 2 equals 2. So it's like, let me change colors real quick. This is not part of the actual graph, but it goes through 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, just like that. And also goes down here. And look what that line does. That line actually bisect, not really bisect, but the graphs reflect across that line. The quickest way to graph inverses is graph one of them, like I graphed that first one. When I graph the square root graph right here, I'm going to change the colors one more time. Almost done here. Hang in there. When I graph this one, I'm trying. Come on now. There we go. When I graphed this one, it went through 2, 0, and 3, 1, which means the inverses got to go through 0, 2, and 1, 3. Okay, because remember what inverses are. Your x's and y's interchange. Okay, so when you're graphing, if you just graph one, interchange the x and the y, you got it. Piece of cake to graph those things. All right, pretty good video. Inverses, 1 to 1, etc., graphing them, finding inverses, all that stuff. I'll see you in class tomorrow. Can't wait.